This is an example of finding probability when you're given mean and the standard deviation. And you look at an example. An example says that in a marriage happiness test, the mean score was 48 and the standard deviation was 5 for a group of 100. We are told to assume normal distribution. And the question is, how many scores were above 43? So before we solve this, we just need to identify the three important variables. The first one is mu. This normally symbolizes the mean. So the mean score of 48, you normally symbolize it with symbol mu bar, and the standard deviation is symbolized with sigma. So we say sigma is 5, and we are given that the raw score x has value of 43. And from what we know about finding the z score, which is the standard score for normal distribution, is normally given by z is equals to x minus mu bar all over sigma. So since we know these figures, we can say that it's 43 minus 48 divided by 5, and this becomes equals to negative 5 over 5 becomes 1. So from that point, we use the standard table for normal distribution that normally defines positive z-score and negative z-score. And for us, we have seen that our z-score is -1, which is -5 over 5. So we want to find the value of probability given the z-score is -1. So we go to the normal distribution table and we can see that z is on this column and it runs from 0 to the point where it's z, and this value normally tells you what is the probability when z is equals to the value given. So when we are given that our z is -1, we are asking ourselves what is the probability that the value is less than from 0 to our value given, which is -1 in this case. So we can see that this is the probability for z is between 0 to -1. So we can see that probability that x is less than 43 is equals to what we have found, 0.1587. But remember, the question is asking when the score is above this figure. So we can see from this figure that we are being asked to find the probability that is bigger than z, from z to the maximum value, which the maximum value is supposed to be 1. Minimum value here is 0. So the best way we can do that is simply by saying that for p x is bigger than 43, we simply say this is equals to 1 minus this probability, which is 0.1587. And what we find, that is equivalent to 0.8413. And now remember, we are told that we have a group of 100. So the normal distribution with the z-score assumes a group of 1. So when you're told it's 100, we just say that the probability that scores are above 43 is that from 100 we will get 84% scoring above 43, and therefore we simply say the probability that the scores are above 43 is simply this percentage, this probability multiplied by 100, which becomes 84. So the number of students who scored above 43 are 84. The next question asks, in the same test or in the same question with the same statistics of 48 and standard deviation of 5 and a group of 100 population, we are told how many scores were below 45. So the question is simply asking what is the probability that x is less than 45. So the first thing is to find the z-score. Z-score is going to be given by x minus mu all over sigma. We know our x is 45 and our mu bar is 48. and sigma is 5, becomes minus 3 over 5, becomes equivalent to minus 0.6. So when you go to the normal distribution table, you have negative 0.6 and this 0.0. So this is the figure that we need of 0.2743. So we can see the probability that Z is between 0 and 0. Or negative 0.6 is given by 0.2743. So again, the probability assumes that the maximum value is 1. So because we are talking about less than, therefore we are not changing that. So we are going to say that if you are given 100 students, you just multiply this percentage with 100. Therefore you say that the number of scores that were below 45 cannot be more than 27. So this is 0.27 times 100 becomes 27. The last question asks, in the same example, how many scores were between 43 and 53? So how do we do that? The question is asking you find the probability that x is less than 43, and then you find again the probability that x is less than 53, and then you take the probability that is higher, you minus the one that is lower. So in this case, we have already found out that the probability when it is less than 43 in our first example was 0.1587, and you can follow the same idea by finding z for the second one, which is going to be 53 minus 48 divided by 5 is equivalent to 5 over 5. So this is positive 1. So you go to the normal distribution table for the positive z score, and you looking for this figure. You can see that the probability that z is between 0 to 1, this figure is going to be 0.8413. So we can see this figure, we can still give it that probability that x is less than 53 is equivalent the probability that z is equals to 1 positive. That is what we are saying is equals to 0.8413, and therefore this is bigger than this one. So because we want the probability between 53 and 43, then we just say 0.8413 minus 0.1587. This becomes 0.6826. Again, we were working with a group of 100, so we multiply by 100. You get that the number of scores that were between these two must have been 68.